So the least common multiple, we are saying this is the lowest quantity that is a multiple of 3 is bigger, so I'm going to be giving my 2 an exponent of 3. And my 3's, I have an exponent of 1 or an exponent of 2. Well, then in this case, I want the biggest one, so I go with the exponent of 2. What we're doing is representing the biggest factors in order to find the least common multiple. But in this case, we end up seeing that we get 8 times 9, which means that our least common multiple is 72. And you can imagine, yes, if we were to list out the multiples of 36, we would get 36, 72, let's see, 108, and so on. And for 24, we would get 24, 48, let's see, we would get 96, and so on. And you see that 7. Now we have another method to go about it. It's called the birthday equation. What we're going to be doing is dividing each of our numbers by a prime number and going until we get a prime number inside the box that is not equal to the other numbers. So we could divide these two by 2. We get 28 and 64. Divide them again by 2 and get 14 and 32. We're still not to a prime number yet, so we keep going. Continue to divide by 2 and we get 7 and 16. Which when we see the 7th, that is a prime number. It's not a factor. Multiply together the 2's on the outside and the 7 and 16. So when we do that, we're going to be doing 8 times 7 times 16. So we see that our least common multiple is 800. To show you another example, we divide it by 2. We get 4 and 6. Again, we get 2 and 3. So we multiply together the 2, 2, 2, and 3 to get 24 as the least common multiple, which is. Okay, So when we, just to make sure that this is very clear, when we have all of the multiples of 8 and 12, we see that yes, 24 is in common, and it's the smallest one that they have in common. With this birthday cake method, and then we'll look at some other ways to not multiply the least common multiple of numbers, but of polynomials. So we're going to divide by 2 here and get 18, 27, and then it looks like of them, so we get 6 and 9, and we divide by 3 again and get 2 and 3. We do get some prime numbers in the box. Multiply 2, 3. So that's 4 times 20. 4 times 27, let's see, is 108. 108 is the least common multiple between 36 and 24. Okay, I'll let you try this one on your own, so you can stop the video and then see that we divide them. We get this and this, so we will multiply 5, 3, 1, and 6 together to get a multiple of 90. Okay, 90 is the least common multiple, even though it is one of the numbers. That's fine. 15, when we multiply it up, we get 90, and 90 is a multiple of itself. Okay, so let's see. We found the least common multiple of 24 and 36, but let's find the least common multiple of 11, 12, and 18. Okay, and in this one, I'll show you again the factorization method, okay, and see how that works. So when we do it, 11, well, that's a prime number, so that's its only factor. 12, we can split into 2 and 6, 2 and 3. So we have 11 here. We have 2 times 2 times 3, or 2 squared times 3. And then for 18, we're going to split that into 2 and 9. 3 and 3. So we get 2 times 3 squared. Well, in this case, we have to have an 11 represented, a 2 represented, and a 3 represented. It just matters how many of each. Well, 11 just has 1, so we have to do just one 11. Between the 2's, I have an exponent of 2 here, so I'm going to give my exponent of 2 in my factorization, or my multiplication here. And then the 3's, this one has an exponent of 2, so I'm going to put an exponent of 2 here. So I'm going to multiply 11, 4, and 9, which gives me 396. Okay, you can try this bottom one on your own, whether that's with the birthday cake method, or in this case with these 3. Looks like you're going to need to have a factor of 7, of 13, and 2 cubed in here. Now, when we get to the least common multiple of monomials, we're going to do something similar to our prime factorization method. And we are going to put them in their prime factorization, so that we get 2 times 3 times x squared times y, and 3 squared times x to the 4th times z. Now remember, we must have all of the different factors represented. So we need a 2, we need a 3, we need an x, we need a y, and we need a z. Just depends on how many of each we need. So we look at these individually and we say, okay, if I need a 2, how many do I need? Well, this is the only one, so we just need 1. How about the 3's? Well, between our 3 squared and our 3, I need a 3 squared, because that's the biggest. Between our x's, I have an x squared and an x to the 4th, so I will take the x to the 4th. And between the y's, well, I only have one y, so I take the y, and one z, so I take the z. So when we are all said and done, the least common multiple between 6x squared y and 9x to the 4th z is 18x to the 4th yz. That is the least common multiple between the two. Okay, so trying another one, we put it in its prime factorization, so we have 2 to the 3rd, x to the 3rd, and 2 squared, 5 times x to the 7th. Well, the 2 needs to be represented, and we take the biggest. The x needs to be represented, so we take the biggest, and the 5 needs to be represented. Okay, so we end up getting 40x to the 7th is the least common multiple. Okay, let's try this one and maybe this one. All right, let me give myself some space. Never mind. Oh, we'll have plenty of space. So when we do this, let's find the prime factorization of all of these. So 6p squared s to the third, we're going to get 2 times 3 times p squared times s to the third. And we're going to get 2m squared s squared. And then we're going to get 2 cubed m to the third p. Now I need to represent everything up here, so it looks like I need a 2, I need a 3, I need a p, I need an s, I need an m. Those are all of the different things that I need. I just need to know which ones I need as far as how big I need. Well, for the 2's, let's see, I have a 2 here, here, and here. So the biggest one is cubed, so I take the cubed. And the 3's, I just have one 3 here, so I'm going to leave it just as 3 to the first power. The p's, I am looking at this one and this one, so p squared and p, so I take the squared. S to the third and s squared. Well, s to the third is bigger. And then m squared and m to the third is bigger. So we end up seeing that we're going to get 24 p squared, s to the third, m to the third. Okay? And for this bottom one, we are going to split it up to say we have 2 times 5 times a squared times c to the fourth. And 15 is 3 times 5 times a cubed times c to the third. So I'm going to need a 2, and I just have 1. I'm going to need a 5, and they're both the same, so I just take 5 to the first. An a, I need an a cubed. The c's, I need a c to the fourth. So I get 10. Let's see. Nope, I'm missing a 3. There we go. I need this 3 as well. So I have 30 a to the third, c to the fourth. And that is our least common multiple. Okay, you can try this one out on your own, put it in its prime factorization, especially those coefficients, and figure out how much of each factor do you need in your least common multiple. Now, with polynomials, if possible, we always have to factor first. Always write any of our factors in prime numbers. For example, if there's a coefficient outside of some parentheses, we would write it as 2 times 3. And you need to include all of the different factors in your least common multiple. So if we have something like 3x plus 1 and 2x plus 9, we can't factor either of those, but we have to represent both of them in our least common multiple. So we would multiply them together. Okay? And you can use your multiplication of binomials to multiply that out using things like FOIL or a box method. Okay, so finding the least common multiple of these two, 2m minus 3 and 5m plus 7, well, we can't factor anything, so we just multiply them together. So our least common multiple is 2m minus 3 times 5m plus 7. Okay, and then let's look at this next one. So with this next one, we are going to be able to factor some things. So we can take a 7x out of the first one and a 6 out of the second one. And then we're going to write everything as prime so that we have 2 times 3 outside. And then just like the other one, I have a 7 as a factor, an x as a factor, an x plus 3 as a factor, a 2 as a factor, a 3 as a factor, and an x plus 3 as a factor. So I need to represent all of those, meaning I need a 7 in my answer. I need an x. I need an x plus 3. I need a 2, and I need a 3. Now this x plus 3 has already been multiplied over here, so we don't need a second one. We can actually leave that out because we already have it represented. We don't need another. So we can simplify to 42x times x plus 3. Okay, let me just try a couple more of these. So factor everything possible, write as primes, put together, and simplify. So in the first one, I can take out a 5p from each of those to get 3p to the first minus 1. And for the second, I can take an 8 out to get 3p minus 1. Well, that's convenient. Now I need to write everything as prime, so we have 5p times 3p minus 1, and 8 can be 2 cubed times 3p minus 1. So I need to have, thank goodness, I have this parentheses that's the same on each side. So I need to represent it just once. So I'm going to say I need a 5, I need a p, I need a 2 cubed, and I need my 3p minus 1. So we simplify to get, well, let's see, 8 times 5, so 40p times 3p minus 1. Right? And you can try this one out on your own. Yes, there is some factoring that needs to be done. Okay, write it as prime factorization, and then, of course, pick out the things that you must have, and don't do any duplicates. Okay, a couple more. Now this is something that will come up every once in a while, so we're trying to figure out this situation. A math test is given every 9 days, a history test every 14 days, the science test every 18 days. How many days will it take to have 3 tests on the same day? What we're really trying to find is what is the least common multiple between 14 and 8. So when we put it in its prime factorization, we get 3 squared, and let's see, times 3 squared. So in our answer, we're going to have a 2, we're going to have a 3, and the biggest is a 3 squared, that's 7. So when we multiply that out, let's see, 2 times 9, 7, we get every 26 days, we will have all 3 tests on the same day. And here's one last one that you can try. Every 24th backpack produced a green stripe, every 60th a big yellow dot, and every